Now we have seen some built-in list functions in Haskell. Let's try to write our own length function, and let's call it length prime. Now length prime of a list of x's. How do we define that? Well, if the list of x's is equal to the empty list, then the length that we return should be 0. Else, we find the length of the tail, so we call length prime recursively on the tail of the list of x's, and then we add 1. So that's one way of defining length prime. Let's see if Haskell likes it. Haskell liked it. Well, now what is the type of length prime? Well, we're getting back a number, are we not? We're getting back a 0. And in this other branch, we can see that we get back something of a type that we can find by adding +1 to something, and plus is only allowed for numbers. So this is in agreement with what the first branch says. So length prime should have a type 2, some number type. What's the argument type? Well, length prime should work on any list. And we are only interested in, or actually only allow lists that can be compared element-wise. We're making a comparison of two lists. So this should be a list of elements of some equality type. And in fact, what we get if we try to find the type of length prime is precisely that if T is an equality type and A is a number type, then the type is T list to A. So that's indeed what we get. That's one thing I don't like about length prime, is that it's not very nicely written. Pattern matching is our friend. Let's try to use pattern matching. Let's delete this and write a nicer length function. And there are two patterns to deal with for lists. One is the empty list. If we have the empty list, then the length should be 0. And here, if we're trying to find the length of a list that's not empty, then it has a head, x, const onto a tail, xs, and then we should get 1 plus the length of the tail, list of x's. Let's see if Haskell likes that. Haskell liked that. In fact, we don't need to know the head, because the head does not appear on the right hand side. So instead of writing x, we could simply write underscore. This works just as fine. Haskell liked that as well. So this is also very often quite useful. If there are some parts of a pattern that we do not need to know, we can simply write underscore for those parts of the pattern. In any case, this is further evidence that pattern matching is our friend. Whenever we write a recursive function, let's try to use pattern matching as much as we can.